Mass casting a part that does not have a flat side requires a more complex process involving the creation of a parting line. This is the model that we're going to duplicate. As you can see, there are no flat surfaces, so no matter how we orient the model, if we just built a frame and poured on top of it, the material would flow underneath and the model would get locked in the mold. Therefore, we create a two-part mold which will have a parting line at the bottom of the car about halfway through the wheels. First, we machined 4 cavities in a piece of wood using a Bridgeport mill. This will allow our model to sit flush against the flat board. This board is now the location of our parting line, and by sitting flush, it allows a tight seal and therefore a clean parting line. We used plasticon modeling clay to secure the model to the plywood and also to fill in the slight gaps along the parting line. This will prevent material from flowing underneath the car. Next, we press the car onto the plywood, and as you can see, the excess clay has squeezed out all around the model. We trim the excess clay and then we press in some additional clay at the wheels and at any other area that did not get completely sealed. To do this, we're using one of Freeman's fillet shaper tools. Next, we apply some Freeman wax release with a white bristled throwaway brush, then lightly buff the wax using a cotton cloth. We are also applying a layer to the model itself to aid in the releasing. Technically, a release agent isn't needed when working with silicone rubber, but the layer of Freeman wax release lubricates the surface and makes the demold process even easier. Finally, using an X-Acto knife, we trim the remaining excess clay around the detail of the wheels. Here is our completed master model with the wheels set below the plywood and clayed in to create a clean parting line. To contain the poured material, we have constructed a two-part wooden frame. The first half is deep enough to cover the majority of the model, and the second half is deep enough to cover the wheels. Now we need a mechanism for the two halves of the model to interlock. Additionally, we need to create a path to pour the material into the mold, called a gate. To accomplish this, we've chosen our Freeman half-round pattern wax, which is easy to handle and non-reactive with the silicone. We choose a length and cut the ends at an angle so the surface will draw easily from the mold, and then we make an identical piece for the other side of the model. We adhere the wax to the wood using clay and then trim the excess. This will create an indentation in the rubber which will later be filled during the second half of the pour, producing a perfect alignment and locking mechanism. Using a larger size of the half-round pattern wax, we create a gate. We mark the end of the frame with a pencil and then cut a piece of the wax to fit exactly between the model and the frame. Again, we use clay to adhere it to the wood. Our model is now ready for pouring. We clamp the frame to secure it in place, making sure the gate is touching both the model and the frame. We are using Rhodia's V340 silicone rubber, which has already been properly weighed, mixed, and degassed. Please view our other video which details this process. This material requires 16 to 18 hours to solidify, so we need to wait until the next day to create the second half of our mold. It has been 16 hours since we've poured the first half of our mold, and the Rhodia V340 has now solidified. Here we are taking off our clamps and then wedging apart the frame to reveal the underside of our pour. The first thing we must do is to remove the residual clay with our fillet shaper tool. Notice how the clay has prevented the silicone rubber from pouring underneath the model, resulting in a very clean parting line for our second half. Next, we remove the locking mechanism. As you can see, a little bit of the material has flowed underneath the half-round pattern wax, which we can cut off with a knife. To complete the cleanup, we use a small piece of folded sandpaper in the groove. The harder silicone rubbers like V340 can be sanded fairly easily to remove small amounts of excess material. The softer rubbers are more difficult to work with sandpaper. After cleaning the excess flash around the locking mechanism, we need to create the other half of our gate to form a wider, round hole through which the material will flow. On one end, we are angling the tip, and on the other side, which will butt up against the frame, we cut at 90 degrees. Before we pour the second half to the mold, it is very important to apply a release agent to the first half. Silicone rubber doesn't stick very well to most materials, but it does stick very well to other silicone rubber. So we are applying Pattern Release 202, which is an aerosol form of Vaseline. A light, uniform coat will be enough to give us a clean release. Next, we place the other half of our mold frame on top and clamp it down. Now we're ready to pour the second half of our mold. Once again, our V340 has been weighed, mixed, and degassed, and we flow the material into the mold as before. It has been 16 hours since we poured the second part of our mold. The silicone is now hard and ready to be demolded. First, we take the clamps off, and using the same wedges as before, we separate the frame at our parting line. Since we waxed our frame, it actually comes off first, and then we separate the mold. Notice our locking device has transferred perfectly from one half to the other. We push the first half out of its frame and then remove the lower part of the gate. Notice that our gate needs to be cleaned up a little bit, which we can take care of with sandpaper, much as we did yesterday when cleaning the flash around the locking mechanism. In order to pour a closed mold, we need more than just an entrance for the material. We also need a vent for the air to escape. We could cast these vents, but since V340 is a harder rubber and cuts very easily, we've decided to cut the vents on one side of the cured rubber. All we need are small vents, just enough for the air to escape, but not too big to require a large repair on our finished part. Since silicone rubber is self-releasing, it doesn't need a release agent. However, in order to make the demolding process easier and to increase the life of our mold, we're going to apply a light coat of silicone spray parting agent. Notice how it gives the mold a higher shine as well. Now we're ready to put the two halves together, and since we've built in the locking mechanism, it aligns perfectly. We tape the mold together with masking tape. We could use clamps, but then we'd also have to use boards on each side to prevent any localized pressure that might distort the mold. This is our Repro 10 tan, which has been agitated, weighed, and mixed. Because of its low viscosity, Repro 10 pours very well. To make sure that we have no air bubbles on the surface of the mold, which might naturally occur around the headlights or other detailed parts of the model, we pour in a little material and then rotate the mold to make sure the entire surface is covered first. And then we finish filling the mold. About 30 minutes later, our Repro has partially cured, but it is still a little rubbery. We want to demold the part now so it is easier to remove the gating system. After removing the tape, we separate the two halves of the mold to reveal our new model. A little material did flow up into the vents, but notice that there is no air entrapment in the casting itself. Now is the best time to remove our gate, while the Repro is hard enough to handle and yet soft enough to cut with a knife. We also remove the part of the gate underneath our model. If we had let this fully cure, we would have had to machine or sand this off, which would take a lot more time. Finally, here is our finished model car, along with our two-part mold. Since we used a high-quality silicone rubber from Rhodia, this mold will produce numerous high-quality parts.